Hello everyone, I am Ishita Singh, student of BTech 4th year, Department of Civil Engineering, Faculty of Engineering and Technology, University of Lucknow. Today I am going to represent my seminar presentation which is on the topic Base Isolation of Structure. Let's see the table of content. This presentation consists the following topics. What is base isolation? Objective of base isolation, principle of base isolation, methodology, isolation component, applications of base isolation, advantages of base isolation, its limitation, and conclusion. What is base isolation? Base isolation is a method in which main structure is separated from the base of footing by introducing a suspension system between base and the main structure. It is also known as seismic isolation system. It is used for protecting structural integrity of building. It is used in earthquake engineering as a passive structural vibration control technology. Objective of base isolation. It reduces damaging deformation in structural and non-structural components, prevent plastic deformation of structural elements, protect the building frame of a structure, protection of non-structural components and contents, protection of life, improvement for the safety of buildings. Principle of base isolation. The fundamental principle of base isolation is to modify the response of building so that the ground can move below the building without transmitting these motions into the building. When the ground moves, the acceleration induced in the structure will be equal to the ground acceleration, and there will be zero relative displacement between the structure and the ground. A building is perfectly flexible, which will have infinite period. In flexible structure, the structure will not move, the ground will move. Let's see the case study. Base isolation system in New Bhuj Hospital is our first case study. The 300-bed Bhuj Hospital that claimed 176 lives when it collapsed during major January 2001 Gujarat earthquake was studied. This was the first new building in India to be fitted with earthquake-resistant New Zealand developed base isolation technology. Structural engineer Dooning Thornton, consultant from Wellington, was the part of New Zealand design team and supervised installation of the first bearing on site in late 2001. This figure shows newly built base isolated Bhuj Hospital in 2003 and also view of basement in Bhuj Hospital building. Second one is Raising Seattle 2004. Here we can see a new alternative of base isolation system composed of common rubber bearing and a sliding rubber bearing is invented for structural seismic mitigation, experimental research on dynamic behavior of the combined isolation system, and seismic response analysis of practical structure with the isolation system are carried out. Story drift, acceleration and shear force responses of structure with aforementioned base isolation and with fixed base are compared. Findings of the present study are the combined isolation system possesses suitable initial and post-yielding horizontal stiffness. CIS has excellent capacity of energy dissipation due to frictional sliding, dynamic friction coefficient and damping ratio of isolation system is approximately 0.8 and 0.15. Third one is Fabio Mazza and Alfonso Volcano. It stated that the non-linear response of typical 5-story RCC frame building with different base isolation system has been studied under strong near-fault ground motions. In particular, a first solution with HDLRB type isolator has been compared with different solutions obtained by means of addition of viscous dampers or steel PTFE sliding bearing. Isolation components. There are two types of isolator that are used. First one is elastomeric isolator and second one is sliding isolator. Elastomeric isolator classified into four parts. First, natural rubber bearing. Second, low damping rubber bearing. Third, lead rubber bearing. Fourth, high damping rubber bearing. Sliding isolators are classified into two parts. First, Brazilian friction system and second one is friction pendulum system. Elastomeric isolator. These are formed of horizontal layers of natural or synthetic rubber in thin layer bonded between steel plate. Here are the figure that shows different type of elastic isolators. These figures shows natural rubber bearing, low damping rubber bearing and lead rubber bearing. Sliding isolators. In this type of isolation system, the sliding displacement are controlled by high tension springs or laminated rubber bearings or by making the sliding surface curve. These mechanisms provide a restoring force to turn the structure into its equilibrium position. Here is a building foundation spherical sliding isolation bearing picture. Application of base isolation. First application in New Zealand in 1974. First application in US is in 1984. In Japan, the first it is used in 1985. US there is 80 buildings and 150 bridges that are made by using this technology. In Japan, 1000 buildings and 500 bridges are made. In India, Bhuj Hospital of Gujarat is made. In Nepal, cases are not recorded yet. Here we can see the movement of building with base isolation versus movement of building with no base isolation, in which one has fixed base and other one has isolated base and there is a ground movement. In the following figures, we can see typical base isolation in modern buildings. This is a video that shows the difference of two buildings. One has fixed base, other one has isolated base. When the ground moves, the behavior of these two buildings are totally different. Let's see the video. Here is figure of San Francisco Airport International Terminal. It is world's largest isolated building. Advantages of base isolation. Base isolation is meant to enable a building or non-building structure to survive a potentially devastating seismic impact through a proper initial design or subsequent modification. The application of this technique can raise a structure's seismic performance and its seismic sustainability considerably. It provides the design profession the ability to design a building that is operational after a major earthquake. Limitations: costly at initial phase of construction, new in term of use, thus facing the resistance to change. It requires higher technology and design. It becomes less efficient for high-rise building. Base isolation can't be done on every structure. For example, it is not suitable for structures resting on soft soil. Let's see the conclusion. Base isolation provides the highest level of protection operational after a major earthquake. Base isolation has significant benefits for earthquake protection of historic structures. Here are the references. Thank you so much for your interest and attention.